Welcome to my another session, and today we are going to discuss about the topic edge computing. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed. That is to improve response times and as well as saving the bandwidth. The origin of edge computing lies in content delivery networks (CDN) that is used in Gmail that were created in late 1990s to serve web and video content from edge servers that were deployed close to the users. In the early 2000s, these networks evolved to host applications and application components at the user interface. This results in the first commercial edge computing services that hosted applications such as desire locators, shopping carts, real-time data aggregators, and ad insertion engines. One definition of edge computing is any type of computer program that delivers low latency nearer to the request. Subsequently, there will be a defined edge in the year 2015, which broadly computed as all computing outside the cloud happening at the edge of the network, and more specifically in applications where real-time processing of data is required. In that definition, the cloud computing operates on big data, while the edge computing operates on instant data, that is, the real-time data generated by sensors or users. According to the State of Edge report, the edge computing concentrates on servers in close proximity to the last mile network. The edge computing is defined as anything that's not a traditional data center could be the edge to somebody. The edge nodes used for game streaming are known as gamelets, which are usually 1 or 2 hops away from the client. The edge node is mostly 1 or 2 hops away from the mobile client to meet the response time. As there is an increase of IoT devices at the edge of the network, which produces a massive amount of data to be computed at data centers, pushing network bandwidth requirements to the limit. Despite there will be the improvements of network technology, data centers which guarantees acceptable transfer rates and as well as response times, which are more critical for many applications. Further to the definition, the devices at the edge constantly consumes data coming from the cloud, forcing companies to build content delivery networks to decentralize data and service provisioning. In a similar way, the aim of edge computing is to move the computation away from data centers towards the edge of the network. By moving services to the edge, it is possible to provide content caching, service delivery, storage, and IoT management, which results in the better response times and transfer rates. The management of failovers is crucial in order to maintain a service alive. If a single node goes down and is unreachable, then the users should still be able to access a service without interruptions. Moreover, edge computing systems must provide actions to recover from a failure and alerting the user about that incident. Up to this, each device must maintain the network topology of the entire distributed system so that the detection of errors and recovery becomes easily applicable. The edge computing brings analytical, computational resources close to the end users and is therefore to speed up the communication speed. A well-designed edge platform would significantly outperform a traditional cloud-based system, that is edge computing. The artificial intelligence tools can run on the edge of the system. This placement at the edge helps to increase operational efficiency and contributes many advantages to the system. Further, the research shows that using resource-rich machines called cloudlets near the mobile users, which offers services typically found in the cloud, which is provided to improve the execution time when some of the tasks are up to the edge of the nodes. Another use of the architecture is cloud gaming, where some aspects of a game could run in the cloud while the rendered video is transferred to lightweight clients running on the devices such as mobile phones and virtual glasses, etc. This type of streaming is also known as pixel streaming. With this, we come to an end of this session. I hope I have given some of the basic ideas of edge computing and its architecture. If you're having any comments, please do comments in my comment section. Thank you.